차렷 인사. Hello, we are G5 students Suha, Jun, Hwimin, and Zion, and today we're excited to share with you some of the amazing things we learned about light in science class.
Light is a very mysterious energy. For hundreds of years, scientists have studied to understand what it really is. But even today, we don't know everything about it. One thing we do know for sure is that light is a wonderful and beautiful gift from God. Let's explore what it makes so special.
So, what exactly is light? Well, it is a form of wave energy that exists in the form of electromagnetic radiation, but it can also be described as a flow of individual and tiny particles. Because light is a wave, it exhibits two important behaviors, refraction and reflection.
First, let's talk about refraction. When the light passes through a different medium, it bends, and we call it refraction. This bending happens because the speed of light changes depending on the material it's moving through. For example, the light slows down more in water than it does in air. We can see this in a rainbow. The sunlight passes through raindrops, slows down, and separates into many colors.
Now, let us show you refraction in real life. We have a simple drawing of an arrow and a glass of water, and I'm going to put this behind the water. Watch closely. Do you see how the arrow looks like it has flipped? That's refraction. When the light travels from the air into the water, it bends, and that's why it looks like it's pointing the other way.
Next, reflection. Reflection happens when light bounces off an object. We can see reflection when we look into mirrors. Mirrors bounce off the light, and the light comes back to our eyes, letting us see our own image. We also see colors because of reflection, as June and Claire will explain in a moment.
But first, let us show you how the reflection works. But because this experiment should be in a dark place, we prepared a video, and please watch it carefully. Can you see it? The light bounces off the surface of water, and that's reflection. When the water is still, it reflected just like a mirror. It's like a ball bounces off the wall when we throw it.
Now let's talk about the colors and how they relate to light. We can see the colors of objects because their pigments reflect certain wavelengths of light. Pigments are opaque substances used to color materials.
For example, we perceive this apple as red because these pigments absorb all the other colors of light except red, which is why we see the apple as red.
The primary colors of pigments are yellow, cyan, and magenta. All other colors are created when pigments reflect wave combination of these primary colors. For instance, the pink paints look pink because it reflects red and blue light. Yellow appears yellow because it reflects red and green. Cyan looks cyan because it reflects green and blue.
Now we will show you how we perceive colors. Here are the cellophane glasses we made. We will first put the red glass on and look at a blue box. Which color do you expect us to see?
When we have the red glass on, the blue that is reflected from the box cannot pass through the cellophane, so we will see the box as black. However, if we see a lemon with these red glasses, the glasses would block the green light reflected from the lemon, and only the red light reflected from the lemon would pass through, which as a result that the lemon would look red or orange.
Now we will put the green glass on and look at the blue box. Again, the blue that is reflected can't pass through the green cellophane glass, so the box looks black. However, if we look at the lemon with green glasses on, we will think the lemon is green because the glasses block the red light and only the green light reflected from the lemon is coming into our eyes.
That's how we perceive the colors, by the light that is reflected and the light that can pass through filters like our cellophane glasses.
This is the end of our presentation. We hope you enjoyed learning of light, refraction, reflection, and color. Thank you for listening. 차렷 인사.